Today I'm going to be going through section 2.6, finding the intersection point of two linear equations using Excel. So if you open up the file, the class file from Lumen in section 2.6, I'm going to go through example 1 and example 2. So in example 1, we're told that we have that children's heights were measured monthly over several years and as a part of a nutrition study. And the data collected on the left shows a sample, so some of the actual data that was collected of children's ages in months together with their height in centimeters. So this input-output table is our actual data. For instance, if this particular child at 18 months had a height of 76.1 centimeters. So when we want to, a lot of times with real data, we want to create a model that would help us predict what height would be in this case based upon the month's age of a child. So the first step that we're going to do is we're going to create a scatter plot of this data. Okay, so I'm going to select the data. This is my actual data. And I'm going to insert, and I'm going to go to this. If you have Windows, it might just say create a graph. In this case, when you drop down, we just want to use the scatter graph. Notice we had been using the smooth line graph up to this point, but when we have actual data, we want to see the actual input and output of our data. So I create a scatter plot, and I take a look here. Okay, and so the first question that you want to ask yourself is, because we're going to do additional types of modeling besides linear data as the course goes forward. So we want to take a look and see, does this data appear relatively roughly linear? Well, it does. It doesn't look like it's curving up. It's not concave up. Doesn't look like it's curving down, concave down. Doesn't look like there's any inflection points. So those are some of the questions I'd ask myself if it looks relatively linear. So yes, it does look relatively linear. No concavity, no inflection points. Okay. So then what I want to do is I want Excel to help us come up with an equation for this and create a linear equation. So if I right click on here, or if you are in Excel, in Excel on a Mac, if you click chart design, you can add a chart element. If you're on a Windows, there should be like a plus sign over here to the right of your graph. And I can input trend line. And so here it gives me the options. Right now I have none selected, so it's not trying to come up with an equation. Then you've got linear, exponential, etc. Rather than just clicking on linear, I like to go down here on more trend line options. That way I can click linear here, but what I want to do is I want to display the equation that Excel comes up with. So I click that display equation on chart. And so now I can sort of drag this over, and when I am on that linear equation, you can see here I've selected trend line equation, gave me the little message. Down here it says I want to have 4 decimal places, 4 decimal places. So notice that on this particular line, I do have 4 decimal places on the slope, but not on the intercept. So you can't assume that it didn't round. We definitely have to go in and we want to click on the graph, and we can see general here. We're going to say number, and then I want to put 4 decimal places, 4 decimal places, and hit enter. And now you can see that we have 4 decimal places for both the slope and the intercept. If you don't do this, your answers in Lumen are going to be incorrect because it's going to be using a different number here. So your answers will be slightly different. Okay, so then if I want to write the equation which I have below here. So I have, and it says use M and H. Okay, those are our variables that have meaning here. I'm going to use M to represent age in months and H to represent height in centimeters. So my function H, height, I input months, and then I have this model. And notice that because I'm using the variable M for months, I've got to have M over here. And this whole thing would give me an output of height in centimeters. So I input months and I output height in centimeters. Okay. It also wanted me to label the input axis and the output axis. So if I want to do axis labels, there's a bunch of different ways you can get to this. Because I'm on a Mac, if I go here to chart element, I can see here I can put axis titles. So my horizontal axis would be, you see how it entered that text box down at the bottom here, and I can say age in months, M. And then I can add my primary vertical, and I can say this is height in centimeters. And that variable is H. All right. And it really is important that you put accurate titles on your graphs so that people are reading those graphs. Up here, I'm going to change this chart title to say, this has created a model for height, and H of M is equal to 0.5709 M plus 66.2628. Yeah, so I can do that there, or I can also update this formula. I don't want X and Y's because I know in this case I've got H's and M's. So H of M is equal to, and I can just go ahead and update to customize my table. All right, so that is the model that Excel came up with. It's a regression model. It came up with a line that best fits my actual data. All right, so then it says use the model and create a new table and graph. Okay, so down here I've already done that, and it's important to make sure that when you're working in Excel, it's clearly labeled. So down here, this is my model down at the bottom. Age, input months, in months, height in centimeters. And so it's telling me here, I want to span my age from 15 months to 35 months, okay? And I want to create a new graph. So I've now taken this formula. This is my model. H of M equals 0.5709 M plus, oops, I have one too many places there, plus 66.268. So I've started my input-output table. So I'm inputting 15 all the way to 35. I filled that in by increments of 1 month. And here I've entered my model. Okay, this is what Excel gave me as the model to predict height. So that's already in there. Okay, so now I want to create a graph for my model. And I'm going to do this. I'm going to highlight my table. And now I'm going to insert a smooth line graph right here. And again, I can customize this. I can say that this is the model. I can give it a name. Model to predict height in centimeters. And again, I can go in on my chart. I can add axes titles. I can say this is age in months, M, etc. Okay, so on your homework, you should make sure that you're doing all of these finer details to label your graph in your table. All right, so that's what the model looks like. Move that back up there. Okay, so then it says use the model. We did that to create, and we label our axis. Okay, so now it says use the model to predict the height of a child that is 22 months old. So they gave us the age of the child or the input. And so what I'm going to do is I'm just going to look down here. Well, I already have 22 entered in my table. So when a child is 22 months old, the model predicts that they are 78.826 centimeters. Okay, so I can write that as an ordered pair. Okay, I can also write that as a sentence. When the child is 22 months old, our model predicts a height of 77.8226 centimeters. Okay, so notice up here, from my actual data, I have 3 data points of actual children at 22 months old. Notice these values are different, okay? And some of them are above what the model predicted, some are below what the model predicted. When you're asking to use the model, you're going to use that formula, that linear equation that Excel came up with. All right, and then the last part says use the model to predict. Whenever you see the word predict or model, again, you're going to use that regression line, and it wants us to predict the age of the child. Okay, so we don't know the age or we don't know the input, and it gave us the output, the height of 70 centimeters. So if I go here in my table, well, my table only goes between 15 months and 35 months, and 74 is the closest number to 70, so we're going to use solver. They gave us an output. We're going to use solver to solve for the age or the input. So if I do data, solver, I want to force that cell B23, I want to force it to a value of 70 inches. And I want to put the input right next to it in column A, row 23. I need to unclick Make Unconstrained, and I'm going to solve. Okay, so we can see here this is very close to 70. If we just do a little bit of formatting here, let me just format that to 3 decimal places. And we get at age 6.546 months, the height is 70 centimeters. Okay, so we want to ask ourselves 6.546, 70. And if you're not really familiar with centimeters versus inches, and you're like, I'm not sure if that makes any sense, there's about 2.54 centimeters per inches per centimeter. So that would mean at 6.5 months, this child is like 27.5 inches tall, which doesn't make any sense. So this is where the model breaks down. This doesn't make sense. And so let's also go back to then it's asking about interpolation or extrapolation. So when we create a linear model, we want to look at our actual data. And in this case, our actual data went between 18 months and 29 months. So our model is going to be best estimating values within that domain of our actual data, within the inputs that we actually collected between 18 and 29. So between 18 and 29 would be called interpolation. It's inside of the domain of our actual data. So all through here, all these estimates or predictions would be interpolation. And anything outside of that would be extrapolation. Okay, so between here and here, extrapolation. Anything greater than 29, extrapolation. And, you know, this is not uncommon for models. You know, they break down at some point. They may only be a good estimate for certain parts of the domain and not others. And that's what we're seeing here. And in general, the model would break down where we have extrapolation happening, if it's going to break down. In this case, the first case, 22 months old, is within the original domain. So this is interpolation. And we can see that it breaks down here. If we continued this table on, let's say we kept going as the child got older and older and older, okay? And if we saw what happened outside of here, we can see that this model, because it's linear, would have the height of the child continuing to grow, okay? And we know that children and adults do not continue to grow as they get older. So as we get older and older, this model would further break down such that it doesn't make any sense anymore. So it would break down as the child gets younger and younger and older. Let's say you are say you're 30 years old, this would say, right, there's 360 months in for a 30-year-old, right? We could express their age as 360 months. This would say that they are 107 inches tall, which doesn't make any sense either.